Hello, Algebra 1 Muffin students. Make sure that you have this paper out that is titled Solving Systems of Equations by Graphing. For the next couple of class periods, we're going to be going over finding the exact same thing, just doing it in 3 different methods. The first method on here we're going to be using is graphing. So just make sure you fill in your notes along with the page, and then next class we'll actually do some practice together. So for the first thing, the solution to a systems of equation is a point or points that two lines have in common. So what we're really trying to do is we're trying to figure out the intersection of two lines. So you're trying to figure out where they cross, kind of what the point is where the two lines cross. That's the whole goal of all of this. So for each one of these, you're going to graph each line. They're 2 separate lines. And the solution of the system is actually just going to be the point where they intersect. So I'm going to graph them using 2 different colors just so it's a little easier to see. This one, as long as they're in y equals form, you can go ahead and start at your y-intercept, which is 2. And then my slope on this one is 1, so we're going to go up 1 over 1. Remember to go down left, and then we can kind of sketch a little line here. You can use a straight edge too if you want to be nicer. And then we're going to graph the other line here, y equals 3x minus 2. So we're going to start at negative 2. And the slope is 3, so we're going to go up 3 over 1, excuse me. So up 1, 2, 3 over 1. 1, 2, 3 over 1. There's this line too. And so looking at there, you can tell that the solution would be the point right where it intersects, which is at 2, 4. So that's the solution. So in all, each one of the ones below in your notebook, when we do this next class, we're just looking to see where the point they intersect at, which is right there. Now how to check it, you basically just take this, plug your point in for x and y into both equations, and it should be equal, so it should prove true. So if I plug in 4 for y to the first equation equals 2 plus 2, that's true, hopefully. And then this one here would be 4 equals 3 times 2 minus 2, which is 6 minus 2, which is 4. So that works as well. So we're going to do the same thing for each one of the ones below. I'm going to do the first one with you, and then you can go ahead and just check over your answers. So I'm going to pause it afterwards. You can solve them and then hit play, and then I'll have the answers up and kind of talk about each one of them. So for these, you're not in y equals form, so I'm just going to copy the first equation down. In order to graph it using slope-intercept, we've got to solve for y. So I'm going to subtract 2x. I have negative y equals negative 2x minus 5. Either multiply or divide everything by negative 1. You get 2x plus 5. So I'm going to graph that line. That would be the same as the first one. It's just in y equals. So I can graph that. I'll just do it in purple. So it's 5 up 2 over 1. You remember you can go down and left. A negative over a negative is still positive. And so there's your equation, your line for that one. And then I'm going to solve the other one as well. So that's going to be negative, I'll just kind of do it over, make sure I'm on the camera. Negative 2x minus y equals negative 1. And then again, I have to divide everything by negative 1. So for this second line, I'm going to start at a positive 1. And then I'm going to go down 2 into the right one. So starting here. And then down 2 to the right one, down 2 to the right one. You can go up 2 into the left one. Hey, look, there it is. It's crossing right there. And so the point of intersection, this looks like is at negative 1, 3. So that would be the solution to your system. So you can go ahead and pause it and then graph the other ones. and then we'll talk about kind of the last part on there. Okay, so make sure that you paused. I'm going to go ahead and show the answers for the other 3. So for this one here, remember x equals is a vertical line. When I solved for y, I got negative x plus 7. Start at negative 7, slope down 1 to the right 1. They cross at 5, 2. So that would look like that. The last 2 at the bottom are kind of special cases. This one here, these lines are actually parallel. So because they never intersect, then this one's going to be no solution. There's nothing that works for that one. And then for the last one here, these are the exact same line. When you graph them, they graph over top of one another. So for this one, they have, remember the answer you're trying to get is what point or points do they have in common, just like we wrote up here. So for this one, it's all real numbers. They have or infinitely many solutions, every single point they have in common. So that kind of brings us to the last part on your notes, which is the different types of solutions. You can have one solution, and that just means that your lines intersect or will intersect. So maybe they're not intersecting in your view, but they will eventually. Another type of solution would be no solution, just like when we're solving equations. No solution is going to be they never intersect, they're always going to be parallel. And the last one would be that when you end up graphing them, they're the same line, which means they have every point in common, which would be an infinitely many solutions or all real numbers in this case as well. So next class we're going to go ahead and review over this. We'll do some practice on it too, but make sure these notes are filled in. All right, I'll see you then. Bye.